Welcome back! We discussed the Unity editor in the last video and made our game's user interface. We also talked about the importance of components on game objects. This video will discuss coding fundamentals and dive deep into why we're writing everything we're coding. Before going into our Unity editor or code editor, I wanted to discuss data and variables. Let's talk about data first. Data is information that is passed around our code. The information can be numbers, letters, words, and true or false. Let's go over each of these and talk about how to write them in code. Integers, or ints as referred to in the C# language, will be our whole numbers. Longs in C# will also be whole numbers. Floats will be decimal numbers, and doubles will also be decimal numbers. So, of course, the question comes up, why do we have two different types of data for both whole and decimal numbers? The answer comes down to precision and performance. Ints and floats hold less data than what is capable of longs and doubles, so you might think they're redundant. You would use longs over ints if you're working with huge numbers, and if you're looking for precision, you would use doubles over floats. But in game development, performance is more critical, so we prefer smaller data to work with because the computer can handle this data much quicker. You'll usually not see doubles or longs used in game development. You just write the whole number to write an int or long. To write a float, you write down the decimal number followed by an f. 3.14f signifies to C# that this number is a float. You write down a decimal number followed by a d for doubles. We understand numbers better in the context of C#. Let's break down words and letters. The data type for letters in C# is called char. Char is short for character, so I guess you could pronounce it char if you wanted to. The data type char can hold a single letter, but when working with letters, usually you want to make something longer than just a single letter, and you can't do that with a single character. That's where our other data type called string comes in. A string can hold multiple characters to create a string of characters. Strings are the data type we'll use most because we're making a text adventure. So to write a char, type the letter you want surrounded by quotes. To write a string, you write the string of letters you want surrounded by quotes. And to be clear, when I say a string of letters, I mean word, sentence, paragraph, or novel. You can add as many characters as you want to a string. Booleans or bools is the easiest and smallest data type. A bool can either be true or false. To write a bool in C#, this is gonna blow your mind. You type true or false. That is what data is. In code, it's different ways to define different types of information. And this relates to variables because variables hold data. Variables are text references that reference data instead of using the data directly. That may seem unnecessary, so let me give you a pertinent example. Let's say that we have a string of a story, and we want to display the string in multiple locations. We can copy and paste the story's entirety into the different places we want to show that story, but if it's a long story, that'll be a lot of text. And if we change that story, we have to go to every instance we wrote down and change it there. Or we can use a variable and hold our story within this variable. And instead of passing our story everywhere, we just paste this variable, then any changes made to the data will also change wherever we use a variable, since a variable is just a reference. Also, a variable can be a single letter, reducing a lot of writing. Usually we don't use single letter variables. It's better to give variable names that are clear and make sense. So in this example, I would probably name the variable story text. The writing seems strange on that. That's called Camal Casing in programming. You don't capitalize the first letter of the word, but capitalize the first letter of every following word with no spaces. That's the proper convention for writing variables in C#. That's variables as a concept, but how do we write a variable in C#? To write a variable, first you write the access level of the variable. I know access levels came out of nowhere, but for now, private is the most secure access level and the one you should use unless you have a reason not to. So we have private, which is our access level, then you write the data type you'll be using. Then you write the variable name. As I mentioned, variable names can be whatever you want, but are usually named something meaningful and in Camal Casing. Lastly, you write a semicolon whenever you finish writing a line of code. Semicolons are the equivalent of periods in regular writing. After you finish writing a sentence, you write a period to signify that that sentence has ended. In C#, you write a semicolon to indicate that your line has ended. I'll walk you through making your first C# script inside the Unity editor. Then I'll present you with the challenge of writing your first variable. To create a C# script, go to your project window and right-click. hover over create and click on C# script. It's vital to name your script immediately after clicking C# script. Don't press anything else, make sure that you name your script. For us, we'll call this script game logic without any spaces. And that's it. You can double click on it, which should open up your code editor. Immediately, you'll see a lot of stuff we didn't talk about. We'll get to it, but for now, I want to throw a challenge at you. After line 6, try to write a variable that holds a string. We're going to use this as the beginning of our story text, so name it something appropriate for that. If you have trouble, don't worry, I'll walk you through it after you give it a shot. Pause the video now and try it out. To get started, let's write our access level. Our access level should always be private by default, so we'll set this to private. The second thing we write is the data type our variable will hold. We're writing the beginning of our story text, which is a string of characters, so we'll write string. The last thing we want to know is the variable's name. We want the name to be easily understandable for others and ourselves, so let's name this beginning story text and just close it off with a semicolon. That's it. Now you know how to create or initialize a variable. At the moment, the variable is empty. To give it a value, we have to assign it its value. To do that, we write the equal sign and put in the information that we want to give it. If you remember talking about strings, you'll remember that a string is signified by having quotes around a text. So let's put some quotes. And now we can write whatever we want. I'm just going to fill in some filler text, but you can write the beginning of your story. A quick thing to note, we don't have to initialize it and assign it a value simultaneously. If we wanted to, we could initialize it the way we did and then assign it a value later on. To accomplish that, you just write the variable name and equal and then the value. We have our variable, but we're not doing anything with it. Let's try writing our story text to the console. Looking at the rest of our code, you can see void start and void update, and above them a comment saying what each of them does. The start is called once before the first frame update, and update is called once per frame. So if we want to write to our console one time, we want to do it inside of the start. If we do it inside the update, it'll run every time there's a new frame, and that just depends on how fast your computer is. Many things can influence how often an update runs in a second, and that number can fluctuate depending on how much code you wrote or if you have other programs running. But usually it's around 200 times a second for a simple game like ours. So how do we write to our console? We type debug.log and then an opening and closing parentheses. Inside our parentheses, we want to put whatever we want to write to our console. In our case, we want to put in our variable. Let's type in beginning story text, and don't forget our semicolon. Save our script with Ctrl S. Now, if we run our game, we should see nothing. We didn't do anything wrong, but we forgot a crucial step. I discussed this a lot in the previous video because it's essential. We didn't add this script as a component to a game object. Let's create a game object in our hierarchy window. Right click and create empty. Let's change the game object's name to game logic, then let's add our game logic script as a component by clicking on add component. Unity should automatically put our game logic script in the script section. Now if we run our game, we should see our text in the console. Great, it's working, but we don't want this to appear in our console because the player doesn't ever see the console. We want it to appear in the story's text area. To do that, we have to go to the game object, select the component we want, and change the text field in the component. So how do we do that? The first thing that we want to do is create a variable to hold that component inside our code. Let's make that variable. First, let's type private. We haven't talked about access levels yet, but this is our access level. Then we want the data type we're holding. But what data type is the TextMesh Pro component? The TextMesh Pro component exists as a class. I know classes came out of nowhere too, but for now, you can think of it as a different kind of data type we can create. But that still doesn't answer the question, what do we write in this data type section? I'll give you the answer now. The class name is tmp_text. Let's name it something appropriate. The text is going to be holding our story text, so let's just call it story text and then a final semicolon. Before we continue, we can see that TMP text is giving us an error. That's because the TMP text class doesn't exist in our code. Someone must create that class for us to store it in a variable. Luckily for us, we don't have to create the class. Someone already made it inside a thing called a namespace. A namespace is like a library filled with code that somebody already wrote. We only have to tell our code that we want to use the Text Mesh Pro namespace, and it should unlock that TMP text class for us. How do we tell our code that we want to use this namespace? Looking at the very top of our code, you'll see 3 examples of namespaces that Unity automatically added for us when we created our script: system.collections, system.collections.generic, and Unity Engine. Now, we just have to add the Text Mesh Pro namespace by typing in TM Pro, then the using keyword behind it, and then closing it off with a semicolon. Once we do that, you should see with our IntelliSense that TMP text is now green and no longer has the little squiggly error underline. Okay, that's 2 new concepts right after each other. To review, classes for our current purposes are a new data type we can store in a variable. Namespaces are like libraries of code that we can access by using the using keyword at the top. We'll talk more about classes later, and I'll give you a little hint. We already created a class of our own, but we'll talk about that in the following video. We have our variable, but we still haven't assigned it a value. We can assign our story text a value in a few different ways. Still, probably the best one is to make this variable accessible in our Unity editor. To do that, we have to give this variable an attribute. All attributes are just a way for our Unity editor to interact with our code. Let's give this variable the serialized field attribute. With that attribute, our Unity editor will be able to see and assign a value to this variable directly from Unity. To give our variable an attribute, before our variable we add an open square bracket and type serialized field, and then close it off with a closed square bracket with a capital S and F. After we save and our Unity editor compiles our code, we can access the variable directly inside our Unity editor. Very exciting! We can now drag our StoryText game object directly into our StoryText field, and Unity will automatically choose the Text Mesh Pro component inside the StoryText game object. We can also click on the circle dot on the right hand side and select it from there. Now, inside our code, the StoryText variable directly references the StoryText game object's Text Mesh Pro component. Instead of using debug.log inside our start, we can set our story text equal to beginning story text, but when we do that, we get another error. Our story text references this entire component, the font size, the font asset, the vertex color, everything, but we don't want to access all of it, we just want to access the text. To go inside the component in our code, we just write a dot after our variable, which should show us everything we can access. You can see many options, but we just want the text, so we can type in text, which should fix everything. Before the first frame update, our code will set the text field in our Text Mesh Pro component equal to our beginning story text variable. Let's run it. You should see that everything is working perfectly. Great, I have another challenge for you. The challenge is a repeat of what we just did, but I want you to create 4 more TMP text variables for our 4 other button texts and assign them in the Unity editor. Go ahead and pause the video, I'll walk you through it if you're having trouble. Let's start with writing our serialized field attribute and then private, our TMP text data type, and let's name it something appropriate like first button option and close it off with a semicolon. And then we just have to do this 3 more times for our other buttons. Let's return to our game logic game object and pull this out. And if you had trouble here with this, you can't drag the entire button. You have to drag the text TMP game object. Let's do it for the rest of them. And now you can see that we're having a bit of a hard time seeing which text component is which. Let's go into each game object and change the name to something more specific. I'll name this button 1 text and then do the rest for the other text game objects. Looking back at our game logic, we'll see that all the button option fields have been updated with the new game object names. Okay, cool. We did a lot in this video. We learned about data, variables, attributes, and namespaces. Next video, we're going to dive into more concepts and turn our story block from concept into an actual object we can make inside of Unity. This video is also the last video this channel launched with. The rest of the videos will be coming out weekly, but if you want access to all the videos right now, you can head over to our Patreon and help support making these videos. If not, click the subscribe button to keep up with each video as they release. Making these videos has been a considerable effort, so I would appreciate you sharing this series with someone interested in making games, and for now there's already a video of me talking about the first game I'm making. It's on screen right now if you want to check that out. Okay, that's it. I'll see you in the next video.